Hi, in this video we will be using a calculator to evaluate logarithms. We are also going to be introducing the common logarithm and the natural logarithm. Alright, so let's do this. So fun problem reads, use the calculator to approximate each logarithm to 4 decimal places. These are right kind of problems. Alright, so I'm going to take out my trusty calculator. I'm allowed to use a graphing calculator, so let's do it. So we have logarithm base I don't know, of 691,450. So one of two things, either because I'm the one that wrote this, I either forgot to write down the base of the logarithm or some magic's gonna happen. Okay, so let's go ahead, take from the top. This is why we don't skip a couple of steps. Okay, common logarithm, what is that? Common logarithm is the special name given to a logarithm of base 10. Okay, so I'm just gonna copy this over because I like to freehand things. So we have logarithm base 10 of x. Cool. All right, so in a textbook you will never see this, not because they don't want you to evaluate logarithms with base 10. It's just that when the base of a logarithm is 10, we typically don't write it, so instead we just omit it. So the moral of this story is this: if you have an expression involving a logarithm and the logarithm is not highlighted, then that means that the base is 10, or it's understood that the base is 10. Okay, now about for another cool name, so natural logarithm. Natural logarithm, what is that? Natural logarithm is the special name given to a logarithm of base e, where e is about 2.7 and I forget the rest. So again, nothing fancy, nothing new. I'm just gonna copy over what we have. So we have logarithm base e of x, and once again you will never see something like this in the textbook, not because you won't be assessed, it's just that not the notation that we use. So whenever we have a logarithm with base e, we typically replace it with the natural log. That's a pretty long word, so we will replace it with ln, which is a notation for natural log. But it is very easy to mistake the lowercase l for the number 1, so I personally like to write it in italics like the books do, but I don't have time for that, so I write it in cursive writing. I forget how to do that. Okay, so whenever you see ln of x, that is the natural logarithm, which is the special name given to a logarithm base e. Okay, so with that being said, let's go ahead back to our first fun problem. Okay, so we have logarithm, the base is not highlighted, so it's the logarithm base 10 of that cool number. Okay, so let's go ahead, take out our trusty calculator. I don't think you can see my screen and the keystrokes, so not a problem. I brought my special effect calculator. Give me a sec. Okay, this does not work how I thought it was gonna work. Maybe if I put this on the side, I think that could work. Yes, no, maybe so. Okay, and then I put my screen right here. I shouldn't suffer that much. I could just make this higher. This is what happens when you're new to making videos. Okay, all right. So we want to enter logarithm of that number. So first I have to look for my logarithm key. So we have log, which is a number that's to the left of 7. So we're going to punch it in. All right, so when we punch it in, we should have log, and then the calculator automatically places an open parentheses, so we want to open the argument, and then we write our argument, and then we close it with the closed parentheses. So we want to take the logarithm of that number, which is 691,450. There is nothing else in this expression, so it's not vital if you close the argument. I do it out of habit, but if you leave it as such, that's it. Then we hit equals, and that gives us about that beautiful number. I forget what we're asked to round to 4 decimal places. So if I keep my cool, that should give us about 5.8398. Sorry, my finger was in the way. All right, cool. All right, one problem down, two more to go. So the next problem, so we have ln of 19.7 and change. So ln, that is the natural logarithm. So let me go ahead, take out my special effect. Where is the natural logarithm? So the natural logarithm, or the ln key, is directly below the log key or to the left of 4. So we punch it in, and we want to take the natural log of 19.722. And then again, you can close the argument. I do that, but sometimes I'm a little lazy and I leave it open. Okay, and that will give us about 2.9817, I believe. Okay, so let me go ahead, put this to the side. So that's about 2.9817. All right, so that's pretty cool. So I hope these are on my test. Sorry, this is what happens when you start boxing things prematurely. Okay, so for the grand finale, we have logarithm base 9 of 78, and this problem makes me pretty nervous because when I look at my calculators, the only bases that I have for logarithms are base 10 and base e. I had a student tell me that that the calculator can evaluate logarithms with different bases other than 10 and e, but I would have to look for it, and if I have to look for it, that's actually gonna slow me down. So the question is, we have logarithm base 9 of 78, so I need to change this base 9 to what my calculator has on here, so base 10 or base e. So that leads us into our change of base rule. What is the change of base rule? So the change of base rule is a rule where you guessed it, where we have to change the base. So I'm going to read this to you, then I'll try to break it down to the best of my ability. Okay, so it says logarithm base a of x equals, you can read logarithm base b of x over logarithm base b of a. Okay, so let me go ahead and write this over. So we have logarithm base a of x. So we don't know what a is, so it's just whatever the problem is, but let's just say that our calculator doesn't have a base a key. Okay, so we need to change it from base a to base whatever our calculator has, which is base 10 or base e. So in this case, we are going to write this as logarithm base whatever we want of the argument over logarithm, same base that we chose initially, of the original base of the logarithm. Okay, so I'm not sure if I was able to convey what I wanted to say, so let's go ahead and look at problem C. Okay, so we have logarithm base 9 of 78, so we are going to use our change of base rule. We're either going to use base 10 or base e. Base e scares me, so I'm going to stick to base 10. So change of base rule, we're going to say logarithm base 10 of the argument over logarithm same base of the original base. But bear in mind that in mathematics, when the base of a logarithm is 10, we never write it, so why start now? Okay, so we have logarithm of 78 over logarithm of 9. The reader would know that if a base is not highlighted, then the base of the logarithm is 10. Okay, so let's go ahead, punch it in. So we have logarithm, let me clear my screen, logarithm of 78, and in this case it is vital that you close the argument because we have a lot of fun stuff that follows it. So we're going to go ahead, divide it by logarithm of 9 equals, and I'm not really good at rounding, so hopefully I get it right, so that'll give us about 1.982, I think that's an 8. Okay guys, so that is it. Gracias.